4-6, square roots and cube roots. The objective is to find square roots and to find cubed roots. The Common Core state standards are listed in the mathematical practices. The first thing that we're going to do is go over square roots. Every positive number has both a positive and a negative square root. Here are 3 different examples, all using the square root of 36. So we have the square root of 36. What 2 numbers multiplied together that are the same give you 36? That would be 6 times 6. So the square root of 36 is one of its equal factors, so it would be 6. The negative square root of 36 means we keep it negative, and the square root of 36 is negative 6. So the negative square root of 36 would be 2 negatives multiplied together to give you a positive 36 underneath your radical sign. So the positive and negative square root of 36 would be negative 6 and positive 6, because negative times negative, or you could write it as using the plus minus 6. So it has 2 different answers. A negative number like negative 36 has no real square root because the square of a number cannot be negative. So if you see the negative underneath your radical sign, it's impossible. You can't do it because what 2 numbers multiplied together give you a negative 36? It would have to be a negative 6 and a positive 6. There's a video link that I found on YouTube if you'd like to watch it. The next is a chart that we're going to fill in. The first is your whole numbers up 1 through 16. The second column is that whole number squared, and the third column is what that number is squared. So if we have 1, we square it, we get 1, because that's 1 times 1 is 1. If we have 2 and we square it, we get 2 times 2 is 4. If we have 3 and square it, 3 times 3 is 9. If we have 4 and square it, we get 16. 5, we square it, we get 25. 6, we square it, we get 36. So pause the video right now, and I want you to complete the table. And then when you're done completing the table, you can check your answers. Okay, so you now have completed the table. Check your answers to see if you are correct. All right, so we're going to find the square root of the following numbers. Number 1, the square root of 100. What 2 numbers multiplied together give you 100? That would be 10. The negative square root of 81, we want the negative square root. So negative 9 times negative 9 gives you 81. So that negative 9 is your solution. Number 3, we want both positive and negative square roots. So 2 numbers multiplied together to give you 49. They're the same as 7. Number 4, the positive and negative root of 169 would be positive and negative 13. The negative root of 21 is negative 11. And the square root of 1 is 1. Now we're going to estimate square roots. So you can estimate the square root of an integer that is not a perfect square. You're going to estimate each square root to the nearest integer, then check using a calculator. So what we want to do is we want to find the perfect squares that fall before 33 and after 33. So that would be square root of 25 and the square root of 36. The square root of 35 is 5. The square root of 36 is 6. So 33 is closer to 36, so our answer is 6. So to find the square root of 33, we do 33 and hit your square root key to give us 5.744, and it keeps going, so it is closer to 6. Number 2. We have the negative square root of 129. So we want to find the negative roots that come before and after 129. So since it's negative, furthest away would be the negative square root of 144 and the negative root of 121. The negative root of 144 is negative 12, and the negative root of 121 is negative 11. So negative root of 129 falls closer to 121, so it's negative 11. Formula D. So to get the negative square root of 129 using a calculator, you would do 129, hit your square root key, and we want the negative root, so it would be negative 11.357, and so on. So it is closer to negative 11. problem solving using a formula and square roots. It says to estimate how far you can see from a point above the horizon, you can use the formula d is equal to 1.22 times the square root of h, where d is the distance to the horizon in miles and h is the person's distance from the ground in feet. The observation deck of Seattle Space Needle is 520 feet high. How far to the horizon can a person see standing on the observation deck C? Round to the nearest tenth. So we're going to use the formula d is equal to 1.22 times the square root of h. We substitute in. We want to find the distance, so we have 1.22 times the square root of 520. You may use a calculator for this, so the first thing that you'd want to do is find the square root of 520 and multiply it by 1.22. So we start by doing 520, hit your square root, times 1.22, and we get 27.820, and it keeps going, but we're rounding it to the nearest tenth, so it's 27.8. And that would be in miles. So that means that if you were on the observation deck at the Seattle Space Needle and it was 520 feet high, you could see about 27.8 miles on a clear day. Number 2, Springport Ledge Lighthouse in Maine is approximately 55 feet tall. Calculate about how far a person who is standing at the top of the lighthouse can see on a clear day. Round to the nearest tenth of a mile. So we'll start by writing down the formula. D is equal to 1.22 times the square root of h. We substitute in. We're trying to find the distance, so we're going to multiply it by the square root of h, which is the height, which is 55. So we can use a calculator. So we are going to start by doing 55, hit your square root, find that first, multiply it by 1.22, and we get 9.047. So rounding it to the nearest tenth, so it's just 9.0 miles or 9 miles. So if you were at the top of the Springport Lighthouse, you could only see about 9 miles if it was a clear day. The next section is on cube roots. We're going to finish the chart below. So in the first column, we have our whole numbers. The third column, we have our number cubed, or to the third power, and the last column is what it is when we evaluate it. So if we have our whole number 1 and cube it, we get 1, because 1 times 1 times 1 is 1. 2, we cube it, so it's 2 to the third power. 2 times 2 times 2 is 8. 3, cube it, so it's 3 to the third power, and that gives us 27. 4, we cube it, we get 64. 5, we cube it, we get 125. So now I want you to pause the video, and I want you to complete the rest of the table, and when you're done, you can start it up again and check your work. So now check your answers and see if you filled in the chart correctly. If you made any mistakes, please fix them in your notes. So we are finding the cube roots of each of the examples. So the cubed root of 8, you can see that the radical has a 3 in it, so that's telling us that we want to find the cubed root. So that means what 3 numbers multiplied together give you 8. So 2 times 2 times 2. So one of its equal factors is just 2. Number 2, the cubed root of 64. What 3 numbers multiplied together give you 64? That would be 4 times 4 times 4. The cube root of 64 would be one of its equal factors, which is 4. Now, number 3, it does have a negative underneath the radical sign. And when we were squaring it, you couldn't do it. It was not possible. But with cube roots, you can. Because what 3 numbers multiplied together that are negative give you 27. And that would be negative 3 times negative 3 times negative 3. So the cube root of negative 27 is negative 3. Now we're going to be estimating each cube root to the nearest integer. So we start by writing the perfect cubes that fall in front of 83 and after 83. That would be 64 and 125, the cube roots of each of those numbers. So the cube root of 64 is 4, the cube root of 125 is 5, so 83 falls closer to 4, so our answer would be 4. The cubed root of 39. So what perfect cubes fall below would be the cubed root of 27 and the cubed root of 64. So the cube root of 27 is 3 and the cube root of 64 is 4. 39 is closer to 27. The cube root of 39 would be about 3.